Question 1 says, Table 1.1 lists some physical quantities. Complete the table by placing a tick next to the scalar quantities. So acceleration, when we write it down, can be a vector or a scalar. So we have to say we assume it's the vector form most of the time. Charge only has a quantity. There's no direction associated with it. Momentum is a vector. That's important to remember. If two things collide head-on, the positive and the negative momentums might add up to 0, so two things can collide head-on and stop, so it's definitely a vector. Power, the energy transferred per second, has no direction associated with it. Energy is a scalar quantity, so power must also be a scalar quantity. Upthrust is example of a force, so it's a vector quantity, so just charge and power. A uniform cylinder has diameter d, length L, and mass m. The density ρ of the cylinder is given by ρ is 4m over pi d squared L. Table 1.2 shows the data obtained from an experiment to determine the density of the cylinder. Calculate the percentage uncertainties of d and L. Write your answer in the table. So the percentage uncertainty is just the uncertainty over the value times 100% to turn it into a percentage. So for the diameter, that gives us 0.4%, and the length 0.6%. We're writing both of these just to one significant figure because the uncertainty has only been given to one significant figure, so we shouldn't quote any more than that. Calculate the density of the cylinder, give your answer to 3 significant figures. So when we calculate the density, we need to be a bit careful with units because we're working in millimeters over here, and we want the density in kilograms per meter cubed. And we're in grams, where we want the value to be in kilograms. But we're just looking at the measurements at this point. We can ignore the uncertainty at this particular point. So when we write it down, we should say ρ, let's use a different pen, ρ is equal to 4 times the mass, so that's 247 times 10 to the minus 3 if we want it in kilograms, divided by pi times d squared, so d is 26.2 times 10 to the minus 3 meters squared, times L, which is 162 times 10 to the minus 3. So as a general principle, rather than trying to do these conversions in our head, we prefer to use the powers of 10 to calculate them. So this gives us an answer of 2.83 times 10 to the 3 kilograms per meter cubed. Calculate the percentage uncertainty in the density. So let's just write this formula out again. Rho is 4m over pi d squared L. So when we're looking at this, we've got a set of quantities that are multiplied together. Our rule is multiplication and division work the same. When m, d and L are multiplied or divided, we add the percentage uncertainties. So the uncertainty as a percentage in the density, so I'm going to write the error in the density as a percentage should be equal to the error in the mass as a percentage plus 2 times the error in the diameter as a percentage plus the error in the length as a percentage. So 2 times here because it's squared, so we're effectively multiplying by d twice. So the percentage uncertainty in the mass is 0.4 plus 2 times the percentage uncertainty in the diameter is 0.4 again, plus The percentage uncertainty in the length is 0.6. So when we add these together, we get our total percentage uncertainty, which comes out as 1.8%. Based on the data that we're working from, I think again we should only really be quoting this to one significant figure, so plus or minus 2%.